Hello everyone, welcome to another Frontier Precision Tech Talk. I'm Drew Johnston and today I'll be talking about the DJI Phantom 4 Pro's camera settings for photogrammetry mapping applications. I'll first explain a little bit about the three pillars of photography. Next, I'll give a summary of the Phantom 4 Pro's automatic and manual camera settings. Then we'll look at some images taken from flights using different combinations of settings and flight speeds. And finally, we'll look at DJI's camera style settings and see if they have any noticeable effect on Pix4D processing. Before we begin, here are a few notes about the DJI Phantom 4 Pro UAS. It's a very compact, versatile, and affordable prosumer drone. It has a very capable mapping sensor for low altitudes that features a 1-inch CMOS sensor to capture 20 megapixel still images and 4K video. A big highlight for photogrammetry software purposes and overall image integrity is its mechanical shutter. Most models under this unit employ cameras with a rolling shutter, which oftentimes create warping artifacts when flying at high speeds. This UAS has a top speed of 45 miles per hour, but I would almost always recommend staying under 25. The three pillars of photography are not often emphasized with newer remote UAS pilots, but the combinations of these three settings can easily make or break your project. If your data is blurry, under or overexposed, it's likely that your camera settings are to blame. It is best to get these dialed in first so moving forward into processing will be easier. ISO, this is the sensor's sensitivity to light. Increasing this value allows for shutter speeds to be increased in low light conditions. But the trade-off is the higher that you raise this value, the more potential noise you introduce into your project, especially in shadows. Aperture refers to the size of the opening that allows light into the sensor. Increasing this value will darken the image, which may force you to slow down your shutter speed to compensate and yield good overall exposure. Shutter speed is the length of time that light is allowed into the sensor. When moving at fast speeds, it is recommended to increase your shutter speed. You can adjust your camera settings in the DJI Go 4 app. The sliders icon on the right of the home screen will open a panel with another slider on top. If you select Auto, the system will continuously scan the image frame and change the ISO, aperture, and shutter settings throughout the flight to yield what it thinks is the best exposure. If you select the M button for manual mode, you can choose what camera settings you want to use, and they will be locked in for the duration of the flight. It's important to note that not all automated flight applications allow you to fly with manual camera settings. For example, Pix4D Capture app only allows you to use manual camera settings when flying through the Android application. A little more on ISO and noise. When zoomed in, we can see a noticeable difference even between low ISO values of 100 and 200. When trying to utilize structure from motion with our photogrammetry software, we often operate on the pixel level to get accurate maps. For this reason, setting the ISO values at 100 is advised to keep noise to a minimum. If you're using automatic camera settings on a project with a vibrant area of interest that includes structures like white roofs or bright sun reflections, you may experience different pixel reflectance values, image to image or flight line to flight line. In the left image, when I was flying over the parking lot, you can see the aperture value was at 5 and shutter was way down at 240. When over the much brighter rooftop, the aperture tightens up to 6.3 and the shutter increases to 800 to compensate for the intense returns. In this extreme example, the software will have a very hard time matching pixels on the edge of the rooftop or in the shaded region. With less common features to choose from, accuracy may degrade in these low confidence regions. A solution for this issue is to use manual settings. While keeping the settings the same throughout the flight, you'll have more reliable and consistent pixel reflectance values for the software to match up between overlapping images. To investigate shutter speed, and its effect on our imagery, I outlined a few combinations of settings that I happened to see when using DJI's automatic settings, as well as picked a couple more extreme examples to illustrate the issue of image blur when flying at 10, 20, and 30 miles per hour. I matched the combinations to try and have a similar overall exposure that you can see on this slide. In the following slides, I'll start with a slower shutter speed and progressively get faster. For the first test, I flew with the ISO value at 100, aperture at 6.3, and shutter at 300. You can see issues even when flying at slower speeds. Resulting data may not be great with these settings and will most likely be unusable when flying over 10 miles per hour. For reference on the size of this target, the white dot in the middle of the circle is 1 centimeter. The second test I flew was with the ISO value at 100, aperture at 5.6, and shutter at 400. The results are slightly better than the first flight, but you would most likely be in the same boat and forced to fly at slower speeds when you're using these settings. For the third test, I jumped up the shutter speed quite a bit. I flew this test with the ISO value at 100, aperture at 2.8, and shutter at 1000. Despite the sun glare angle on the 30 miles per hour image, you can still clearly make out the center white dot on the calibration board. The last test I flew was with the ISO value at 100, aperture at 2.8, and shutter at 1600. At this zoom level, it would appear no different from the last flight using the 1000 shutter speed setting. The resulting images have clear definition around the edges. If we zoom in a little bit more on the pixel level between the 1000 and 1600 shutter speeds, you can see a very slight difference even at the 20 mile per hour flight speed. It isn't much, but you can see the amount of white space on the 1600 setting is less than the 1000 setting. These higher shutter speeds can come in handy when you need to precisely click on aerial GCP targets in post-processing software to gain absolute accuracy for a project that requires centimeter level accuracy. Another very important setting that is often overlooked is the camera focus. By clicking on the AFC MF button in the DJI Go4 app, you can switch between using auto and manual focus settings. Choosing AFC will scan the image frame throughout the flight and adjust the focus based on what the camera sees. For manual focus, the user will set an appropriate setting first that will be locked in for the duration of the flight. When flying over somewhat homogeneous land cover at high altitudes, using automatic settings may not be an issue. Other times, depending on the reflectance, observed structures, or even what flight planning software you're using, you may run into some focus issues. Here's an example from one test where I had a processing error. I inspected the images after processing and found that my entire first flight line was out of focus. There's nothing you can do at this stage besides reflying the mission or removing the entire flight line from the project, which I end up having to do in this example. A possible solution for consistent focus issues is to set it to manual. There are two common ways to do this, depending on the flight planning app that you're using. I would recommend that when on the project site, take off using the DJI Go4 app and bring the UAS to the planned mission altitude. I like to find and set my manual camera settings at this point, and if necessary, you can set the manual focus here. First, select AFC and push with your finger on the center of the frame. Then click the MF button to lock in this setting. Land the UAS, force close the DJI Go4 app, and launch your automated flight planning app to use these settings for the mission. The other way to set manual focus is to click the MF button and then the infinity button on the bottom of the focus slider bar. This does not always work well, however, we do encourage that you test different approaches and see what works best for your applications. Here are some other DJI camera settings that are recommended for mapping missions. Keep the image size at 4:3 to utilize the most area possible. Most photogrammetry software packages use JPEG as the acceptable format. Set the white balance to what is appropriate for the conditions during the time of the flight. Keep the color setting at normal. Be sure to enable MF Focus Assistant in the Gear Settings tab. If you haven't heard of the style settings before, there are options for image processing via the Phantom's camera. You can adjust sharpness, contrast, and saturation of the images. The style options for each category range from -3 to +3. There has not been much said about these settings for mapping applications, but the processing for each image may affect how quickly the camera can trigger due to additional processing time, but this has not yet been tested to a fail point. I flew several combinations of the style settings and could not see much of a noticeable difference between them. On this slide, you can see the standard image without style processing on the top, and the bottom we have +2 sharpness and +2 contrast. Again, not much of a visible difference. I wanted to see if Pix4D could detect more of a quantifiable difference between the normal and style enhanced images. So I flew the same flight plan using no enhancements, and again immediately afterwards with +1 sharpness and +1 contrast. My initial hypothesis was that the mission with the enhanced style settings would produce more usable tie points than the mission flown without enhancements. To my surprise, the results from Pix4D's quality report show the mission with the image style enhancements did not perform as well with the mission without them. The enhanced style plan produced roughly 11% fewer key points than the non-styled plan. However, it's important to note here that these results are from one experiment, so there may be more to learn about these style settings. But for now, I would suggest keeping them 0, 0, 0 and not changing any of the style properties. To summarize what we've gone over, use manual camera settings for dynamic landscapes with a lot of variance in reflectance, such as white roofs, sun glares, etc. Keep the ISO values at 100. Keep the shutter speed over 1000 if possible to avoid motion blur. Adjust the aperture and shutter combination to get the best exposure. Use manual focus to avoid blur issues. For areas with lots of vertical relief, try increasing the aperture size, which will adjust the depth of field for focusing. You should also try slowing the shutter speed to compensate for the higher aperture to reach an acceptable exposure. You may have to slow the aircraft down to avoid motion blur. Finally, changing the style settings is not recommended, as Pix4D did not show us any improvements during the initial pixel matching process. Change these up depending on your applications. No two flights are the same, but to have repeatable results requires following best practices and testing camera settings that work for your applications. Thank you for tuning in. Again, I'm Drew Johnston with Frontier Precision. See you next time.